This video is going to be about representing forces with vectors and also representing interactions using free body diagrams. When you finish this video, you should be able to identify interactions with objects, represent these interactions with vectors, and label the vectors properly using the double subscript notation. Let's start with an example. First of all, I want to remind everybody that a vector is any quantity that has magnitude and direction. Examples of vector quantities that we've studied: acceleration, velocity, displacement, and now force. We can represent vectors with an arrow, because an arrow can show an amount. There's a greater amount than that, and it can show direction. This isn't all that new. We studied vectors a little bit back in our one-dimensional motion unit. Now what we're going to do is apply vectors to representing forces. Let me pull up a new page here. And so I'm going to draw a little picture here. This is some kind of platform, and on the platform I'm going to put a spring, and on the top of the spring, compressing the spring a little bit, I'm going to put a balloon, maybe a balloon filled with water, so that squishes the balloon down. And what we want to do is represent all the interactions with the object. In this case, let's say the balloon. Interactions with balloon. Okay, so first thing interacting with the balloon is the spring itself. That's pretty obvious that it is, because there's contact there. That's a good sign of an interaction. But there's another object interacting with the balloon that's not so obvious, and that's the Earth. Now the Earth interacts with the balloon in the way that the balloon and the Earth pull on each other with a force called gravity. Obviously you've heard of that before. We call the force gravity, but the object that's interacting with the balloon is the Earth. Now, some of you might see this platform as playing an important role in the situation, and maybe it does. But the platform isn't directly interacting with the balloon. In fact, the platform isn't interacting with the balloon at all. And so we have just two things interacting with the balloon, the spring and the Earth. What we're going to do now is represent those interactions. In other words, draw a picture of those interactions. So here's a box, nice simple shape. We're going to use that to represent our balloon. And we're going to label on our balloon both these interactions. So first off, we have the spring. The spring is pushing up on the balloon, and the Earth is pulling down on the balloon. Now at this moment, we don't really have any idea of which of those two interactions, forces, are larger. Well, you might have an intuition about it, but we've introduced no physics that would allow us to suggest which of those two are larger. So I'm just going to draw them the same length for now. Alright, so this is a start at what we call a free body diagram, FBD. It's a free body because we isolate the balloon from everything else in terms of drawing the picture, but we recognize that there are a couple of interactions with it. Now, the next thing that we want to do is label these vectors. And so we're going to do that like this. This we're going to label kind of like this. We're going to use a capital F for force, and then we're going to use a double subscript notation like this. Spring on balloon. Spring on balloon. Okay, so this designates the nature of the interaction, just a generic interaction, and this tells us the two objects that are interacting. Now over here, this we're going to label like this. W, E, B. And the reason for that will be in part 2.